Hi guys, hope you all doing well. So here we are going to analyze each and every question of CSIR Net November 2020 Chemical Sciences with best conceptual analysis along with extra information which may helpful for you for your further preparation. So watch the video completely and click on like and do subscribe our channel, and if you are interested you can visit and join chemmasters.online website for the best concept-oriented courses and to practice very high standard online test series and mock test to boost your success rate. Okay, now just come to the point of question. The calculated heat of formation for NaCl2 and CaF is. So just look at these ionic compounds. Are they normal? So they are simply abnormal because in nature we can see NaCl and CaF2 but not NaCl2 and CaF. Okay, right. So to give answer for this question, I'm going to give the basic conceptual analysis. Okay, before going to justify it with Born-Haber cycles. Okay, right. Now just look at NaCl2. So where sodium is in +2 oxidation state and each chlorine with -1 oxidation state. Okay, in CaF calcium is in +2 oxidation state and fluorine must be -2 oxidation state. Okay, right. Now just to take the sodium, we know that sodium is having 11 electrons, right? And if it lose one electron, then it will get Na plus, that means a +1 oxidation state with 10 electrons. We know that the 10 electrons or equals to the neon electron configuration and simply neon electrons, and which is the most stable electron configuration or electrons for that sodium plus. Okay, and we know that whenever the electron removed from the outer shells of atom or element or ion, we need to add some energy. We call it as ionization energy. Okay, so these are the very basics, so we learn at our school stage, right? Okay, then the ionization energy, which is indicated with plus here. So the first ionization energy from that sodium to sodium plus is very less. Why the less amount of energy required here? Because by just losing that extra electron, that is the 11th electron, sodium gets 10 electrons, that means which is going to give the stablest electronic configuration. Okay, so that's why it can easily lose electron by just giving small amount of energy. Okay, now consider from sodium plus to sodium plus 2. Okay, right. Now here, by just removing that 10th electron, it will become +2 oxidation state with 9 electrons. So here the stablest electron configuration is simply removed and it is attaining fluorine electrons. So 9 electrons, just like fluorine. Okay, so the stable sodium plus is converting to unstable sodium plus 2 whenever that 10th electron is removed. So to remove that electron, we need to give high amount of energy. Why should we give that high amount of energy? Because sodium plus is in already in stable form, so it is not interested, it is not going to give or not going to lose its electron to become once again unstable. So we need to give more and more energy. So here we can say the second ionization energy is high, so very high. Okay, now for that chlorine 2 Cl minus So here chlorine has 17 electrons, and by just adding one extra electron it will become 18. We know that, which is of argon, so which is the stable number of electrons for that Cl minus, and which will become more stable when we compare with that chlorine. Okay, right. And we know that here, whenever the electron is added to the outer shells of an atom or molecule or ion, the that means here the sum of the energy is released into surroundings, and we can call it as electron affinity. So energy is releasing from that atom or molecule or ion, so we can give with minus sign. Okay, so here the first minus here electron affinity for that chlorine to Cl minus is very less. Why it is less? Because by just if it is going to add one electron, it will become more stable in the form of Cl minus. That's why here the less amount of energy is released from that. Okay, right. Now just here the formation, the enthalpy of formation of NaCl2. So here we need to take the sum of here ionization energy plus sum of electron affinity of the ions which are going to make that particular ionic compound. So you can see the high plus IE1 and plus IE2 will become the, so here we can just say the big plus value. Okay, so here when we compare with this electron affinity, so here the enthalpy of formation will be in positive value. So just subtract this. Okay, because it is the here what we say, the minus value is very less when we compare with this positive value, that is ionization energy value, which is the sum of first ionization and second ionization of sodium. Okay, so that's why here the enthalpy of formation of NaCl2 must be positive. Okay, right. Now just come to the point of Cl, that is CaF. Yeah, here just take it Ca, and we know that which is having 20 electrons, right? And in the next case it will become Ca plus 1, that is 19, and next it will become Ca plus 2, which is having 18. So in the first case, what we say, one electron is removed, here the second electron, the first electron here, the second electron here. So for the first step to become 19, we can say some ionization energy, that is the first ionization energy, and here we can take the second ionization energy. Okay, right. And which is 18 electron, that means will be the most stable cation of this calcium. That's why less amount of energy is required to remove this electron from that calcium plus 1. Okay, now just come to the point of fluorine, and here fluorine is having 9 electron, right? So by just adding one extra electron, it will become F minus by just having 10 electrons, and we know that F minus is stable because it is attaining neon electrons or electronic configuration, right? In the next step it should be converted to F minus 2, that means one more electron should be added for this. But here is the question, here is the thing, that means whenever the one more electron is added, it will have 11 electrons, which is very unstable. That means it will gain sodium electronic configuration. That's why to add this second extra electron, most of the energy should be released from that F minus. Okay, so here for the first step we can take the less amount of electron affinity, and whereas for the second electron, that means to add the second electron, F minus should release enormous energy or lots of amount of energy. So that's why here we can get the biggest negative value for that second electron affinity from that F minus to the F minus 2. Okay, right. So that's why here when the enthalpy of formation of a CAF, now just we need to take the sum of ionization energies plus the sum of electron affinities. So just check here, the that means electron affinity is the largest negative value when we compared with this positive ionization energy from that calcium to calcium plus 2. That's why here we can get the enthalpy of formation in negative value for that CAF. Okay, so based on this theoretical explanations, we conclude that option 3 is the correct answer for the given problem. Okay, so if you are interested, and we can go with the Born-Haber cycles. So for that NaCl2 and CAF, yeah, here Born-Haber cycles are used to determine enthalpy of ionic compounds. Okay, that is what we know. Right, now here, so first the sodium, that is the solid sodium, should be converted to gas of the sodium, that is gaseous sodium. We can call, that is the conversion of solid to gas, as sublimation. Okay, so solid sodium is converted to gaseous sodium. So the formation, what we say, the change in enthalpy of sodium solid to sodium gas, that is the sublimation, is calculated as plus 108 kilojoule per mole. Okay, now sodium gas should be converted to sodium plus gas. So that is the first ionization energy, which is equals to 496 kilojoules. Okay, now from that sodium plus 2 to sodium plus 2 gas. So here the second ionization energy, which is calculated as 4562 kilojoules. I already told you that when we compared with the first ionization energy from that sodium to sodium plus is very less when we compared with the second ionization energy, that is to form Na plus 2. Okay, now just come to the point of chlorine. So half Cl2 gas is that means Cl2 should be dissociated to form single chlorine gaseous atom. So we can call it as mathematically the change in enthalpy of dissociation of that diatomic chlorine, and which is equals to plus 122 kilojoules. Okay, now chlorine is converted to Cl minus, so that is electron affinity, so that is the minus 349 kilojoules. Okay, so Cl minus gas. Now Na plus 2 and Cl minus gases combined to produce. So before that, I'm just going to give for this Na plus and Cl minus, that is the general or natural sodium chloride formation or ionic compound formation. Okay, so Na plus gas and Cl minus gas, so to produce NaCl solid or ionic compound, for that the lattice enthalpy or lattice energy is equals to minus 788 kilojoules. Okay, right. So here we can find the enthalpy of formation of NaCl equals to here the enthalpy of sublimation plus first ionization energy plus the second ionization energy, and here delta H dissociation of the chlorine gas, and electron affinity plus the lattice energy. Now just substitute all these values, we will get the positive value 5590. Okay, so when you just if you are going to find for that NaCl2, so we need to consider Na, that means ie2 also. Okay, so ie2, and then for that 2 moles of Cl minus, that is we need to add 2 into Ea, so 2 uh, electron affinity, that is 2 into minus 349. So just do that. In that case also you will get the positive value or positive enthalpy of formation. Okay, right, now just try to look at that CaF formation. So here for that CaF formation, first thing we need to look at the calcium solid, and which should be converted to gas. Further, the enthalpy of sublimation equals to 178 kilojoule per mole. Now calcium gas converted to calcium plus 1 gas, that means first ionization energy equals to 589. Now calcium plus 1 gas converted to calcium plus 2 gas. Okay, that is the second ionization energy equals to 1145. You can see the difference here. Now just come to the point of fluorine gas, that is diatomic gas, which should be dissociated to form single monoatomic gases. Okay, so for this the change in enthalpy of dissociation equals to here 158. Now for the first ionization, or sorry, first electron affinity, that is by just taking one electron it will convert it to F minus gas. So for that the electron affinity is very less, already we have just discussed in a theoretical way, that is minus 328 kilojoule per mole. Okay, now for the second one, that is F minus gas, by just taking another extra electron, the electron affinity will be in minus 5000 around kilojoule per mole. Okay, so after taking this we need to find the total enthalpy of formation. Just take the sum of all of them, and the lattice enthalpy, that is almost minus around 1000 or 1200 for this formation of the normal CaF2. Okay, so we need to take for that lattice energy of that ionic compound which is observed in the nature. So in the nature it will be observed in CaF2. For that the enthalpy, the lattice energy is around minus 1200. Now you can get the value, that is enthalpy of formation of CaF is absolutely in the negative value. Okay, so here as I said, if you go with the theoretical, because in examination we cannot almost all we cannot have the idea on all these enthalpy changes and dissociation energies. Okay, so if we have the concept, right, that means a theoretical conceptual analysis, then we can answer this question easily, right? So thank you very much.